So hey guys, this is Ayusing, and in this video what we're going to do is I'll make you familiar with the large margin classifier, and we can think of it as a support vector machine as a large margin classifier. And I will give you the intuition behind a large margin classifier. So first of all, let's recapitulate about the previous video, what we have learned. The thing that we have learned about the cost function, if just a quick overview, which is the j of theta equals to this thing that is a c is the regularization parameter, which is a 1 by lambda. It is just the thing that lambda here. Okay, and in this we want our cost of 1 of z, and z here is the theta transpose x would be the greater than or equals to 1, because we want where y equals to 1, and where y equals to 0 we want cost of 0 of z, and here z is the theta transpose x would be smaller than or equals to -1. We are not taking 0 because we want more accurate predictions. Okay, so that was the quick recapitulation of my previous video. But in the support vector machine and logistic regression decision boundary, so let's make this let's say these are the data points and these are something kind of, and in the logistic regression we simply make this for separating the minus and the plus, or the positive and the negative examples. Okay, and here we have the same thing, the cost function j of theta, and if we take c here to be very large, something like 1 lakh, no, yeah, 1 lakh. So if we take very large, then this whole equation, this whole summation from here to here would be equals to 0. Now if we set this on something constant, we choose that kind of theta parameters, we want this to be equals to 0. So we have to choose that kind of theta parameters so that it can equals to 0. And by doing all those kind of stuffs, we are going to get the c times 0 plus 1 upon 2, all summation r equals to 1 to n theta squared z. And again, if I remove this, 1 upon 2, r equals to 1 to n theta squared z. Okay, and we want our theta transpose x, we want our theta transpose x or with the greater than 1 or the -1, just I talked just before a second. So we have again a new optimization objective, which is j of theta equals to 1 upon 2. If our c is very large, then I equals to 1 to n theta squared z. Okay, this was the optimization objective that is not required, but if you want to get into mathematics for large margin classifier, then we will make use of this. But if you're not getting that, don't worry about it. You will get to know in the time that you will making forward and learning machine learning forwarding. And also I would like to note here is that if you're not understanding any kind of concept, don't worry about it, don't demotivate it, because I also, when I was a beginner, I also not used to understand everything, whatever I saw in the book or in the research papers. I just think, oh yeah, I will learn some. If I face the algorithm again, I will learn definitely, or I will see that kind of something kind of key that will make me understand this kind of support vector machine. So don't worry about it, don't demotivate it. This is just something called a small topic which you will be getting if you face this kind of problem. Just try to set in front of your computer and take a copy and start writing whatever I'm just explaining you here. Okay, and we just make this kind of equals to 0, so that we have to take that kind of theta parameters would be equals to 0. So after that we c times 0 is we get to know about this. Okay, so in logistic regression decision boundary, we make something like this. Something like this, and we don't have to worry about it. We just have to make, if this is something kind of, let's say that this one, and what I can do, I can just make a non-linear curve. It is not that kind of, it does not have that kind of special property. But the special property what the distribution support vector machine has is the support vector decision boundary wants to go far away as possible, make the far away as a possible negative and the positive examples. So let's take a look at the support vector machine large margin classifier linear separable. So first of all, the decision boundary has a special property that is far away, that I'm just highlighting you here, is the far away possible from negative and positive examples. What the support vector machine wants, is just wants to make as far as possible as it can be by dividing the positive and negative examples with the support vector machine decision boundary. So let's make a decision boundary here, and this is my decision boundary, and how we can take the length. Oops, what is happening? Yeah. So if we take this is my kind of the decision boundary, and there is a lot of there is a lot of distance between the positive and the negative examples, and for that we'll show one more line, and these distance are called large margin classifiers. Or you can say this is just as a margin. And the support vector machine always wants to maximize this margin. Our support vector machine always wants to maximize margin. So it can separate positive and negative examples. So that was the linearly separable if C is very large. Again, if C, our regularization parameter, is very large, then it will plot a linear line, and if you reduce, it will look something like something like this. Let me draw this, something like that. Okay, so don't worry about it. We'll get to know about that also. So let's say if our support vector machine or a decision boundary in the presence of outliers, how our support vector machine will perform. Our support vector machine will only plot a straight line by here, because there are a lot of margins. But this is the case when we have large C, which is a regularization parameter. But if we reduce C, or if we decrease C, it will go something like this. This is the decision boundary. Okay, and this is just the same thing. If we reduce our C, and C equals to 1 upon lambda. You can just think of it as a C. You can just think of it as a C as a lambda. By increasing lambda, you fix that. By decreasing lambda, you fix that. And I think that is pretty much clear to you about the support vector margin classifier. Again, I'm recapitulating again this one. This is linearly separable, and this is called the margin, and the support vector machine always want to increase that margin so that it can separate out positive and the negative examples. And in the presence of outliers, if you reduce C, if you wish, then it will perform good and it will tackle the outliers. Now I think that that's it for this video, and I hope that you got better intuition about the large margin classifiers, and if not, please feel free to comment it down below. I'll be happy to answer that. Okay, so I think that I have given you much information about the large margin classifiers, and if you want to get to know about the large mathematics behind large margin classifiers, then please comment it down below, as large mathematics behind large margin classifiers is not need not to be that kind of difficult, or it is an optional, because it just makes a line what the decision boundary and is the only thing. But if you want, please drop and comment. I'll be definitely making a video on that. So in the next video, maybe I'll be bringing up the mathematics for this kind of the large margin, or I'll proceed further with the support vector machine kernels if I get any kind of comment down below. So that's it for this video, and I hope that you got a better intuition and knowledge from this video. I'll be catching up in the next video. Till then, bye bye.